Learning is a very interesting process. When it comes to science learning, it becomes little complex because for science learning, one needs a theory base as well as strong laboratory. And even in laboratory, if one adds demonstration experiments, science learning becomes an interesting thing. It makes the fundamentals more clear, and not only that, it adds future in relation to the subject. Very few people do this. We have with us Mr. Devadas,
Hello.
who has done a very pioneering work in development of demonstration experiments. Mr. Devadas is a retired senior manager. He was in Bell. In fact, he was in corporate R&D at BHEL Hyderabad. We are going to talk with him about this very interesting process of development of demonstration experiments. With me, I have Professor D.P. Khandelwal, who is the present president of IIPT. Professor Khandelwal has done very interesting and pioneering work in physics education. Mr. Devadas, it would be very interesting to know how you got interested in this field.
In 64, I was teaching electrical winding to artisans, foremen, engineer trainees in BHL Haridwar. I always found one thing, the link between why and how was missing in that practical approach. So I took the example of rotating field and developed some models. It was liked by everybody. Then I got the confidence by making suitable models, we can make most of the abstract subject very interesting, catchy, and that gave me a lot of confidence. And I started working on other models also.
How you got interested in this field of electromagnetism?
The reason is I like electrical engineering because I'm an electrical engineer. I was working in an electrical engineering product factory. So I developed, I think I must do some contribution in this field in the real aspect where there is a gap.
But I find many interesting things here, many interesting gadgets. What's that on the
Yeah,
left hand?
this
You know,
is-
that it seems very interesting.
Out of sheer love, I call it mother coil. I don't know whether you agree with me. This is a coil, an electrical coil connected to the wire. Through this PVC pipe, I have inserted some steel wire, a simple coil. I can, in other words, I can say it is a magnetic field generator, AC generator of field. It generates the field. It gives the field when I switch on this supply.
So you-
magnetic field.
So you mean if I apply
230
conventional
yes,
230
it is
volts,
designed for 230, it's available everywhere.
and one should get AC
AC field.
field.
This
In-
core here, how did you get the core here? This one.
This is a PVC pipe. It is discarded by an electrician. He has thrown it. I have picked it up and I have passed. This is the armor used in our power cables. No, I have not taken any established stampings for this.
Soft iron.
So this is also soft iron. For this purpose and for instantaneous use, this is more than enough. Why should we waste money for that? This gives all the
But
result.
if I want to test, now suppose I plug it
That's a good
and I want
thing.
to test whether there is really AC field coming. How
And
can I do that?
I would like to say this is a sort of breakthrough. You know, magnetic field itself is an abstract thing.
Yeah, it's a very abstract thing.
And in this, we can just understand where is the field, what is, whether it is very strong or whether it is very radial or linear. What I have done is I have taken a piezo buzzer connected to a coil. When I bring the coil close to it, wherever you find magnetic field, this blows. It works from 3 to 27 volts. The intensity depends upon the voltage. The voltage depends upon the magnetic field. So the direct indication of the intensity of the magnetic field is heard by the piezo. And
So you mean
no imagination, you really enjoy, yes, where it is here more. Not only that, I can show all around what is the nature of the field. I can also make this field to pass through this straight and show that we can get maximum energy conversion if it is passing right in the center of the coil at right angles to the coil. And all that, everything is straight, seen and done. And,
that makes the
yeah,
concept
it,
very
it
clear.
makes it so. I mean, it is not only that we enjoy it. That
Yeah.
we enjoy this.
There is more
activity.
fun in that.
Yeah, fun. And the basic concept enters the mind in a very enjoyable way. Afterwards, when we read the books or the text, it becomes more meaningful and purposeful.
Yeah, I agree. I find that there are also some permanent magnets there.
Yeah, this is again the concept of permanent magnet at school level, even at college level many times, we are restricted to a bar magnet or at the most to a horseshoe magnet. Here I have taken a magnet which is circular and just by adding one bolt here I have made it rotatable. That's all. This is again a very interesting thing to our teacher friends and students also.
What is
Now
the
I'll just show an advantage. This is a ferrite magnet.
Correct.
Ferrite magnet and taken at a throwaway prices.
Okay.
You can just see, we know that unlike poles attract each other. It is physically seen.
I see.
It is so enjoyable. You see, children, why everyone? Why children? Because these are not limited only. Now, another thing is, I'll just take this and try to rotate the top magnet. Bottom, no, we have created a magnetic gear. And if there is a linear motor circuit, we can just say where are the magnetic field, where is north, where is south, it goes on rotating this. It is very, very interesting actually.
No, but here you are changing the magnetic field by rotating those things. Can I go in a different style? Suppose I use the coil here.
Another use I am just telling.
Yeah.
The same field, when I am rotating this is a coil, I rotate the magnetic field here. By this rotation, as it every time rotates, it is cutting this coil, it is inducing a current. And the nature of the current is 0, plus, 0, minus. It is alternating current. In other words, the alternator, how it works in slow motion can be seen. The generation of alternator, when I have to connect a center of galvanometer here. It's so easy.
But this coil, I mean, you have used a particular gauge wire,
yes,
and
yes.
how did you go about that?
This is done on a former and hand wound. And all the binding and other things are done, and some scrap material. Again, this is in a PVC pipe here. It's a base, a wooden base here, some steel plate in that so that you should have some sufficient weight. And this.
I see the usual method of showing Faraday's effect is to take a bar magnet out.
That's right.
Here
We need not restrict ourselves only to that experiment. This is a real situation of an alternator. A magnet rotates. We don't take a linear motion in an alternator. This is practically very close to the practical aspect of the alternator.
So you have a distinct advantage here.
Yeah.
I can see that.
We can see the current positive 0, negative 0. It is just a slow. All these things are handmade, hand-held, hand-operated, no sophistication, mostly scrap
The other
material.
alternative also in the
Yeah,
coil is
this
turning,
the difference again I have used here a magnet which was removed from a wiper motor, and this is the coil. Here the magnet is stationary, the coil is rotatable, unlike that. Another style. In both the ways, we just only what is needed for the coil is a varying magnetic field linking it. Can be shown. It takes few minutes. Not only that, the core, the magnetic core, I have just put a bolt. For this purpose, a bolt is more. We need not put any engineering materials in this.
Yeah,
And you remove this without core.
I find that you have used also a cap. of,
yes, this is the cap of the bottle.
Yeah, ordinary bottle.
Yeah, this is a
So,
wooden
I mean,
piece. Wooden piece.
That shows that if one has a desire, one can really make wonders from scraps. Mr. Devadas,
What is that angle there? Yes, here.
You have a close look, sir. You can also see inside there is a coil, thin wire is put, and this is connected in parallel to a set of light emitting diodes.
I see.
You know, they work in only in one direction when you connect DC. When you connect to AC, only at positive cycle there will be glow, negative there will be. That means it gives 50 flashes per second. But when a girl wears this and comes close to an electromagnetic field here, they will also glowing, and the effect of transducer goes to the mind through a great enjoyment of a real history in her life. So
What is the
they will all
estimated cost of LED today?
LED cost anywhere from 75 paisa to 1 rupee of
I
this
see.
nature,
Not
of
much
this
cost.
type.
And power input needed?
It takes about 5 to 6 milliamperes at 3 volts.
Very good.
So one can really make some simple things.
Yeah,
and
this now we can straight say even with the minimum field, we can pick up what is the information available here, and those things are called transducers. And here this is indication. What is the indication? Giving you enjoyment is the indication through a transducer. So why not we take science in a different way? And I think.
Yeah, I think it's quite interesting.
Yeah.
What is this? This I find another interesting
Yeah,
demonstration.
this is a disc. Again, I have used the same light emitting diodes.
Okay.
All around, and this is a spool of a tape recorder.
Oh, you
The
mean
coil is in that,
Mhm.
and they are connected here. Here we can rotate this on this shaft. If I rotate, what happens is there is flicker by the LEDs. They try to just give the flashes, and it rotates. As it flashes, it is trying to compare its own speed and gives a stroboscopic effect. In the process, what happens many times you'll find the yellow moving forward, green moving backward,
Yeah,
yellow
yeah.
mixing with red, and this can be shown here with the help of the mother coil at a distance, close as a transducer. There is no electrical connection absolutely. Or
mounting
take it
arrangement.
a mechanical support and rotate it. You get the beautiful stroboscopic
Yeah, that-
effect.
I think that's
Here the magnetic induction, transducer effect, then the rotational effect, plus the stroboscope, and ultimately the illusion which confuses and makes us to believe something which is not real. All these things are involved in one disc, and people really enjoy this.
Yeah, I can imagine that. Mr. Devadas, I think you must have developed many more gadgets than this, and you must be using them for doing demonstrations, presentations in schools and colleges. So how long you have been doing this now?
My demonstrations I am doing from almost 30 years.
Last 30 years?
30 years, but I have intensified it much more after my retirement because people want it, and I have time for them. I must do it, and I feel it is an opportunity given.
So you must have traveled almost the
Quite
entire
a long,
country?
yeah, quite.
So say after retirement, you must have done about how many
After
shows?
retirement itself, around more than about 640 demonstrations I have done.
40 demonstrations.
And the rotating field, which gave me NRDC award, it is another enjoyable model I have done it. That is for few thousand times I have done it in the last 30
What
years.
is so interesting about that rotating field?
You know, this rotating field is an abstract subject like any other magnetic field, which is the heart of all AC machines. How to link the graphical analogy of three-phase system when you apply on a stator, how we get rotating field is a difficult thing. That is one aspect. The other aspect, when we have the rotating field, what are the uses? How to convert this to a torque, a rotational torque, and what is the use of the torque, like squirrel cage motor, slip ring motor, one drone motor, double cage motor, synchronous motor, and it goes like a story, a sequence.
Yeah, I think this is even interesting to not only to
Everyone,
science
everyone,
students,
yes,
even
popular,
engineering
it's like a
students.
popular.
Yeah, it's a very
I
popular
have
way of
given
putting the
demonstration to a
science.
set of villagers because they know about a motor and lot of other machineries, and they enjoyed how this is how the motor works, is it? And really I enjoyed it.
But suppose, I mean, well, this may come not only to my mind, but any viewer, a school may like to have your program.
Yes.
I mean, I'm quite sure that you are willing to go and show
Not
people.
only like, let me tell a very great secret in this, all the progress of these things, my respected audience like students, teachers and professors at various organizations, they are more responsible, their contribution is 70%, mine is 30, it is their feedback, it is their anxiety, it is their suggestions, corrections that has made this. And ultimately that's why they like it. I am just an agent.
I got to know what you only at the convention of the IAPT some 6 months back. Now supposing we want you to meet physics teachers at various places and maybe train and orient some
Yeah,
people.
if some
Would you
5
like
or 6 institutions or different places group together,
to-
take the responsibility of the organizing the aspect. I can't do because so much of correspondence. I am prepared to go and make a little small camp-like thing and serve as much as possible.
Right.
For that, a bit of trouble is to be taken by the organizers.
I think what you have done is something very wonderful, because what you have developed is only through scrap, and all this material can be used to do beautiful experiments, not only beautiful experiments, but the experiments which make the concept very clear to students. And I think that is where the student community has much to learn. And I think much more than student community.
The teachers also have to learn.
Yeah, it is teachers who can do wonders. Because what we have seen today, Mr. Devadas, he picked up small things from the things lying around him, produced beautiful gadgets which can be used for showing fundamental concepts in electromagnetism, which is such an enchanting thing, which is such an interesting thing. And not only that, these equipments are low cost and make the concept very clear. I think that is the message, Mr. Devadas, your work has given not only to our students, but to our teacher community. And I would like to thank you for coming here
Thank
and
you very
showing
much, sir.
the things
Thank you.
what you have done for us. This is something very revealing. Thank you so much.